session 3 of chapter Gravitation. In our previous sessions, we have discussed what is gravitation, what is acceleration due to gravity, what is Newton's law of gravitation, what are the Kepler's laws of planetary motion, what is a satellite, how the satellite can be launched, and what is the escape velocity of a satellite, what is the orbital velocity of the satellite. Now we are going to study in this session about geosynchronous satellite. What is a geosynchronous satellite? Geosynchronous satellite is a satellite which is at rest with respect to the Earth. That is why we are calling it as geosynchronous. Geo means Earth and synchronous means in sync with the motion of the Earth, or it is also called as geostationary satellite. Again, geo means Earth and stationary means it is at rest. So what do we mean by this? For example, this is the Earth and this is the satellite moving around the Earth. Now the Earth is also rotating along its own axis. Okay, it is spinning along its own axis, and this satellite is also revolving around the Earth. So suppose if this satellite is revolving along with the Earth, can you see this? So if it is at this position, the cap is in position with this part of the marker, then as the marker rotates, even the cap is also rotating. That means the person who is standing here is feeling that this cap is at rest. Although both of the objects are rotating or both the objects are moving, the one who is seeing or the one who is on the satellite and the one who is on the Earth, both are feeling that they are at rest. So therefore, we say that the satellite which is at rest with respect to the Earth, it is not at rest. It is also moving, Earth is also moving, but they are moving together. That is why we are also calling it as geosynchronous. It is in sync with the motion of the Earth. Right? So what are the orbit called as? The orbit of such satellite is called as geosynchronous orbit. So the motion, the path which the geosynchronous satellite follows is called as the geosynchronous orbit. Right? Now, for this satellite to be a geostationary satellite or for it to be a geosynchronous satellite, it has to follow some conditions. What are those conditions? Conditions for a satellite to be geostationary. Now, when the satellite is revolving around the Earth with the same speed or along with the Earth, the time period for it to complete one revolution should be the same as that of the Earth to complete one spin. That is, the time period has to be 24 hours. The time period has to be 24 hours. Time period of the geosynchronous satellite. The second condition is the direction of rotation of satellite about its axis must be same as that of the Earth. Suppose this is the Earth and this is the satellite. If the direction is different, obviously they both are not said to be at rest with each other, with respect to each other. So therefore, for them to be at rest with respect to each other, the direction of rotation should also be the same. Right? And the third main point is the height of the satellite above the equatorial plane must be approximately 36,000 kilometers. Now, how can you say exactly that this height has to be 36,000 kilometers? Now, using our Newton's law of gravitation and the properties of satellites, we get a formula called as height is equal to t square r square g upon 4 pi square raised to 1 by 3, that is the cube root, minus r. So what are the values we are going to substitute here? T value is 24 hours, which are multiplying with 3600 seconds, so that you convert 24 hours to seconds. Then we are substituting the value of r, radius of the earth, which is 6.4 into 10 raised to 6 meters, and g is 9.8 meter per second square. So when I substitute all of that and I simplify, I get around 35,930 kilometer, which I will round up and say that it is approximately kept at a height of 36,000 kilometer. So this is how we calculate the height of the satellite, and these are the conditions for the satellite to be geostationary or geosynchronous, right? Now what are the uses of these? Why do we require geostationary satellites? They are used as communication satellites to send messages, to telecast TV channels, okay? So if suppose the geostationary satellites are not used for communication satellites, or some other satellites are used for communication satellites, what happens is the time period is not 24 hours. If the time period is not 24 hours, the signal does not reach the receiver at the right time. Now since the time period is 24 hours, both the bodies are moving at the same pace, both the bodies are moving together, the signal is reached immediately, or you can say instantly, right? Secondly, they are used as weather satellite. Now if I have to say I have to find out the weather of today at around 9 a.m. and if my satellite, the signal reaches the satellite at around 10 a.m. and I get the information at 11 a.m., then I don't require such satellite. So for me to have the proper information about the weather forecasting, I require a satellite which is moving along with the earth. So therefore, geostationary satellites are used as weather satellites to forecast weathers. They are also used to explore the upper region of the atmosphere. And lastly, they are used to know the exact shape of the earth. Right? So these are some of the uses of geostationary satellites. Our next topic is weightlessness. What do we mean by weightlessness? Weightless. So there is no weight. So the state at which the body possesses zero weight, we're calling it as weightlessness. Have you ever thought of having a zero weight? Or you stand on a weighing machine and the weighing machine shows that your weight is zero. It's not possible, right? So now let us first try to understand what we mean by weight. Weight is the force of attraction exerted by Earth on the body. So usually weight is nothing but the force. So we can say it is equal to m into g. That is mass into acceleration due to gravity. So what is actually happening? So when I press a body on the surface of the earth, the force of attraction which is pulling this particular body, this is added to the mass of the body. So we get weight to be equal to mass into acceleration due to gravity. Now what happens when astronauts go around in the spacecraft? Now when a body tries to go in a circular motion, the gravitational force is converted. The force of gravitation is converted, or it is used to get converted into centripetal force. So that means we have Gmm upon r square is equals to mv square by r. So we have Gm by r square is equals to v square by r. So we see that as the velocity goes on increasing, the weight of the body goes on decreasing. So at a particular velocity, what happens is the complete gravitational force gets converted into centripetal force, and at that time this weight becomes equal to 0. And when the body possesses 0 weight, we are calling that particular state of the body as weightlessness. The same thing happens with the astronauts in the spacecraft. So as they keep on rotating, revolving around the planet, the circular motion, the gravitational force is getting converted into centripetal force, so that the spacecraft or the satellite has to be in a particular orbit. So when that happens, the velocity which it attains to be continuously used to revolve around the planet is converted into centripetal force, and at that time the weight of the body becomes equal to 0. This also can be observed when there is a bad lift and you suddenly fall down, the lift suddenly falls down, and suppose you're standing on a weighing machine, you will be able to see that your weight becomes equal to 0. That is when this G becomes equal to 0. Your mass is going to remain the same, but your weight is going to be equal to 0. Right? So this is the concept of weightlessness. The next topic is about GPS. GPS. What is a GPS? It is a global positioning system. Global positioning system. Nowadays, it's very common for us to use this GPS system. Many of us are using it to locate places. We're using it in the traffic. We're using it to locate whether there is traffic or not. We're using it while driving for a longer distance. We're using it to share locations to others so that they can reach us, and so on. So this system is being used by us because of 24 GPS satellites which are placed above the earth. And there are 4 such satellites which are positioned right above certain places, so that each person or each human being is able to access the location, access the atmosphere, access the traffic, etc. using the global positioning system. So this is what we are doing with satellites. So what are we doing with satellites? We are finding out what is the weather. We are determining the weather forecasting. We are able to use it for weather forecasting. We are able to use it for communication. We are also able to use it in military to find out where the troops are. We are also using these satellites to find out where are the flood hit areas. We are also using it to find out the drought areas where there is famine, right? So we are using satellites for any number of purposes in our daily life, and that is being done just by knowing the concepts related to gravitation, satellites, weightlessness, etc. This is all about gravitation. In the next session, we will solve a few problems related to this chapter. Thank you.